Welcome to this explainer. Let's jump right in, because right now, as we speak, there is a literal life or death climate battle raging over the Indian subcontinent. It is a story of catastrophic heat, a global meteorological monster, and an oceanic savior that might just be India's only hope. We're going to break down the mechanics of this crisis, looking directly at the data, the atmospheric science, and the historical records to understand exactly what is happening to the weather in India. The stakes are unimaginably high, so let's get right to the facts.
Okay, so take a look at this staggering reality. On June 1st, the temperature in Delhi hit a record-shattering 52.3 degrees Celsius. This isn't just an uncomfortable heat wave, It is a rapid climate and health emergency. Every major news outlet reported this horrifying statistic. 3,400 people in India lost their lives to heat stroke. But here is the most chilling part about that number. That wasn't over the course of a year, a month, or even a week. That was 3,400 lives lost in a single solitary day. It's a number that completely pulls the ground right out from under your feet. And honestly, this brilliantly illustrates a much darker truth hiding behind the official reports. The sheer scale of this crisis is actually vastly underestimated. If you read the fine print in these official news reports, they openly acknowledge that the actual number of heat stroke deaths is much, much higher. Why? Well, because countless deaths literally never received the heat stroke label in the official government paperwork. So if the official numbers are already this terrifying, the unspoken reality means the situation has already escalated far beyond what is publicly recognized.
Which brings us to the main antagonist of our explainer. Things are poised to get even worse, with some projections actually fearing a peak of 10,000 daily deaths from heat stroke. To put that into perspective, that is 2.5 times the all-time peak death count of COVID-19 in the country. The culprit behind this? An emerging weather pattern that scientists and the media have dubbed Godzilla El Niño. Now, it's not a giant city-destroying movie monster, but its impact on the climate is absolutely just as devastating. So what exactly is this monster, and can anything actually stop it? Part 1. The villain, Godzilla El Niño strikes. To answer that, we really need to understand the villain. Consider that right now, out of the 100 hottest cities in the entire world, a staggering 98 of them are located in India. The heat is multiplying at an incredible rate. Back in 2024, having 37 cities cross the 45-degree mark was big news. Now, projections for the near future show that number doubling to over 74 cities. This rapid doubling is being driven directly by this incredibly powerful Godzilla variant of El Niño. Let's compare normal conditions to this absolute nightmare. Normally, the Pacific Ocean has a beautiful balance. The western side, near Australia and India, is warm, while the eastern side, near the Americas, is cool. This temperature gap creates an air pressure difference, which pulls the trade winds from east to west. It's a balanced system that brings healthy monsoon rains to the Indian belt. But during El Niño, that temperature difference shrinks. The pressure drops, and those vital east-to-west trade winds slow down, or they even reverse. The Godzilla El Niño is an exceptionally strong version of this, and when you combine it with the global weather damage we're already seeing from rising carbon emissions, it creates an absolute drought catastrophe for the Western Pacific.
So the crucial point is how this meteorological anomaly actually translates into human suffering. India is fundamentally an agrarian economy. 47% of the entire population relies on agriculture for their livelihood, and it makes up 18% of the national GDP. This entire economic engine depends on one single source: rain. When Godzilla El Niño delays or completely destroys the monsoon, we see a brutal domino effect. Delayed rain leads to crop failure. Crop failure leads to a massive surge in food inflation. Vegetables and daily necessities become completely unaffordable. It gets so severe that it forces the Reserve Bank of India to make harsh policy shifts just to keep the economy afloat.
And history gives scientists and economists every reason to be terrified. According to reports from institutions like IIT Gandhinagar, El Niño has knocked on India's door 16 times since 1950. Out of those occurrences, it triggered 5 severe, devastating droughts, with major historical droughts noted in 1918, 1965, 1972, 2002, and 2009. But this time, it's a Godzilla event, totally amplified by global emissions. The entire Pacific Ocean wraps around the globe, meaning India really has no way to hide from its effects. Or do they? Part 2. The Savior. The Indian Ocean Dipole. This is exactly where we shift from despair to cautious optimism. While India absolutely cannot control the vast Pacific Ocean, they aren't entirely defenseless. Nature actually provided a localized counterweight right in their own backyard. It's a geological heavyweight called the Indian Ocean Dipole, or IOD, and what's really fascinating is how simple the concept actually is. If you look at a map, India's landmass essentially splits the Indian Ocean into 2 halves, the western side near Africa and the Middle East, and the eastern side near Indonesia.
Usually the temperatures in these two halves are basically identical, but just like the rest of the Earth, the ocean goes through cyclical changes. When a massive temperature difference develops between these two sides of the same ocean, boom, it creates a dipole.
Let's break down exactly how this acts as India's savior, specifically what we call a positive IOD. Step 1. The western Indian Ocean near Africa gets unusually warm. Step 2. This warm water releases massive amounts of vapor, creating a giant low-pressure zone in the atmosphere. Now remember your basic science. High-pressure air always rushes toward low-pressure zones to balance things out. So step 3, cooler air from the east comes rushing toward the west. Step 4, this movement pulls massive amounts of atmospheric moisture along with it. Once that moisture hits its saturation point, it bursts into heavy rain over the African and Indian subcontinents. It directly fights back against the dry winds of El Niño.
Part 3. History, 1997 versus 2019. Let's see how this actually plays out.
So, we have a global monster in the Pacific creating a drought, and a local savior in the Indian Ocean pulling moisture back. Can the local savior actually win? To answer that, we have to look at the historical data. And I do have to warn you, while the IOD is incredibly powerful, history proves that it is wildly unpredictable. Let's look at two fascinating case studies. The year is 1997. The strongest El Niño of the 20th century arrives. It was so terrifying that the United Nations General Assembly actually passed a resolution begging countries to cooperate, and climatologists warned that the Indian monsoon would totally fail, leading to widespread famine. But then, a literal miracle happened in the data. Between June and September, Indian rainfall didn't fail. It actually saw a 2% increase, with some areas seeing up to 10% more rain than average. It took scientists 21 years to fully understand why. They published an analysis in 2018 revealing that a positive IOD had developed over the Bay of Bengal, completely neutralizing the Godzilla El Niño and saving the season.
But before we celebrate too much, let's look at 2019. This year saw the strongest IOD index ever recorded, and the extremes were terrifying. Over in the east, Australia suffered devastating droughts and fires, over 5.5 million hectares burned, thousands of homes destroyed, and 25 lives lost. In the polar opposite west, Africa saw catastrophic flooding that took 85 lives. Naturally, everyone assumed India would get massive immediate rain, but the Indian monsoon was delayed by 7 deadly days. June rainfall was so catastrophically low that early crops were entirely ruined. Yes, by late September, the positive IOD finally kicked in, bringing 10% to 50% excess rain. But the timing was completely off. The deadly delay had already caused massive agricultural ruin. The savior arrived, but it arrived way too late.
Part 4. When will relief arrive?
Which brings us sharply back to the present day. We know the monster is here. We know the savior is forming. But as we just learned from 2019, timing is literally everything. If the positive IOD is delayed, the drought and the deadly heat strokes will claim thousands of lives and devastate farmers. So, what is the scientific forecast for this year? When will the relief actually arrive? For this, we turn to the Japan Meteorological Agency, the JMA. They were the first to accurately predict the arrival of El Niño, and they are now tracking our localized savior. According to their official timeline, we won't see immediate relief. The positive IOD emergence is only predicted to truly begin in mid-July. That means until then, the tragic heat strokes and crop struggles will likely continue. However, by August, this oceanic counterweight should really hit its stride, pushing the monsoon to its peak. If this timeline holds, by October, we should see a full recovery of the weather patterns and a massive relief for agricultural yields.
We are essentially watching a high-stakes geological chess match play out in real time. The Godzilla El Niño is doing everything it can to bake the subcontinent, while the Indian Ocean dipole is gathering strength to unleash those much-needed monsoons. The science tells us relief is on the horizon, but every single day of delay has a profound human and economic cost. So I want to turn this over to you, the folks living through this data. Has the rain finally reached your city, or is the heat wave still winning the battle? Share your localized weather reality down in the comments below. But as you watch the skies, ask yourself this. As global emissions continue to rise, how long can we truly rely on local saviors like the Indian Ocean dipole to fight off increasingly monstrous global heat waves? Keep observing, stay cool, and thanks for joining me for this explainer.